Hello everyone, welcome to this multi-part video series delivering self-service private cloud. We're almost halfway through in this video series and we hope you're finding the video series useful. And as usual, my colleague Pramod is again here with me today. Welcome back, Pramod.
Hey, Satya, thank you so much for having me again.
Awesome, man. So in our last episode, we covered the exciting world of Kubernetes automation with VMware Cloud Foundation. And in this episode today, we'll be diving deeper into database automation. So Pramod, let's dive into the topic of the day, that is database automation with VCF Automation.
Sure, Satya. So the plan today is to again cover the VCF automation that empowers you to define, manage, automate your database infrastructure, ensuring efficient and scalable operations. So yeah, let's get started.
Absolutely.
So just to set the stage here, once again, ARIA Automation is an automation solution powering the VMware Cloud Foundation. Delivers the self-service automation with governance and resource lifecycle management across the VMware clouds as well as the public clouds. So this is a snapshot of several features or the areas that we have been focusing on from the capabilities perspective throughout this video series. And I'm sure you're liking this video series so far. This episode, we will focus on another critical capability, and that's mainly around the database automation. Essentially, I'm going to cover a VMware Data Service Manager. We will call it as DSM. So that enables the application team, database teams, and the infrastructure admins to leverage the supervisor services along with the infrastructure as a code capabilities to deliver a simple self-service consumption of your databases and the cloud infrastructure resources for the VCF or VMware Cloud Foundation in your private cloud. Starting out with some of the common challenges, consider environments where an application developer needs a common data service. For example, a database. They may need to open a ticket to the data team. The data team might need to engage the infrastructure team, which could be another ticket, to create a VM, to figure out where to put the database, which basically the infrastructure admins or vSphere infrastructure admins defines those parameters. So if either a data team or the infrastructure teams are tied up in some sort of severity one issues that they're handling at this point in time, then the application developer could be waiting for a long time. It could be hours or it could be days. To get their database provision, right? So Satya, what do you think? Are the application team going to wait?
Yeah, in normal situation, right? In many enterprises, that can happen if we don't have automation and this kind of self-service thing in place. And in my own experience in olden days, I have seen that happen actually. That actually happened, right? So sometimes they may have to wait, like you said, days, sometimes even weeks, sometimes even months. If the infrastructure team doesn't have enough infrastructure ready, right? That could happen.
Right.
So yeah, how do you mitigate this challenge then?
Yeah, so in general, what I have seen, what some of the application team, they do is they end up downloading few containers, standing up the database in the VM that they already have access to. And essentially, when the application team do this leads to a number of issues for the IT teams. This could be around your resource management, visibility, compliance, backup, patching, security, and so on, right? So it could lead to a development team spending valuable time to build their own databases rather than having a option to consume and provision this database with the self-service capability. And that's the theme for this episode as well. So this is where we see VMware's Data Service Manager or DSM fitting into the picture perfectly. We can offer self-service provisioning of the data services to the end users or even to the database teams, which giving the IT admins or the vSphere admins full control over the resource consumption as well as the visibility into the resources, visibility into the usage, and providing features such as automated backups, automated lifecycle management of those databases and things like that. Yeah.
So things like patching, updating those databases also fall under this, right?
Correct. Yep. So let's deep dive into this. So from the DSM or Data Service Manager, we focus on three most popular databases, as you can see on the screen. So the product combines features that serves the three personas, and we focus on those three personas, such as the application team, the database team, and the infrastructure admin. Yeah. So DSMs or Data Service Manager focuses exclusively on the vSphere and become a native platform extension so that the customers can manage these most important and popular databases like PostgreSQL, MySQL, AlloyDB. By the way, the AlloyDB is in tech preview at this point in time, right? So
so this AlloyDB, this one is Google AlloyDB, right?
Yeah, exactly. This is the Google Omni AlloyDB. Yeah. If you notice in general, in the field that we have observed, application teams have jumped onto the Kubernetes bandwagon. So they do this for infrastructure and application lifecycle orchestration. DSM 2.0 provides a Kubernetes API that enables self-service through similar ecosystem of tools. So the teams that have embraced ARIA automation will be able to continue using that for the self-servicing capabilities with this data services as well. Now, application developers, the other personas, provision the database programmatically with the specification and the policies that they need. They can integrate database monitoring with their application observability because their focus is on application most of the time, and database plays very critical role. Even they can have a control of their database configuration, things like choosing a number of replicas, picking up the right high availability principles and protection policies across the lifecycle management of their applications, right? And then the final personas that we also want to focus here is the database team. Now, database team can take advantage of the Kubernetes style declarative for data service specifications. This means the configuration changes are simply changed to the specifications and applied through a Kubernetes style desired state reconciliation process, which is pretty common when people use Kubernetes APIs and Kubernetes CLIs and things like that. So with all this, data teams become more productive through the specification of deployments and the management of databases. They define and certify the data service templates, define the backups, DR policies for different use cases, and have a single view whereby they can monitor and manage the database's desired state as well. We have seen so far from the application team personas, we have seen the data teams or database personas as well. Now, how about the infrastructure admin personas? Because they have visibility directly through the vCenters. Once they have the visibility through the vCenters, they can create those infrastructure policies, which can be applied to the self-service capabilities. At the same time, DSM or Data Service Manager from VMware facilitate the dependencies on the virtual infrastructure admins. This is where the data teams can work with infrastructure teams in order to do the resource management, setting up the backup locations, and providing those delegations to infrastructure teams to manage the backups and recoveries as well if they wish to.
Right. So if I have to ask you, right, so what is the advantage of using Data Service Manager as compared to the traditional way of deploying your, for example, MySQL database or PostgreSQL database in a virtual machine? What is the advantage that DSM brings?
Right. We have been hearing a lot from the customers that they want to focus on the open source databases such as PostgreSQL or MySQL. You understand these are the open source databases. The most critical aspect of these databases are they're holding the data, critical mission critical data. How do you get the support for it? Right. With the DSM, obviously, this is as part of the VMware Cloud Foundation. The VMware will provide support. Besides that, if you have the private AI licenses where you need these vector databases using the DSM as well, you can get the vector databases using the DSM. And then VMware also provides enterprise support to the customers who have the private AI licenses along with the databases. Yeah.
Right. That is enterprise support for both MySQL as well as PostgreSQL. Is that right?
Yes, that's correct.
Cool. Awesome. Yeah. And I think one thing I can think of is like we were discussing earlier, the patching, upgrading, all of that is also carried by the DSM itself, right? The service will actually provide those.
Yes, exactly. So you're right on the point here to ask me about the patching and the lifecycle management. So BI admins can create the infrastructure policies that they define, how the resources needs to be consumed by the application team or the data team. These infrastructure policies are built using the vSphere client or the Kubernetes gateway API. Now, once you have access to the APIs or to the UI of DSM itself, essentially from DSM point of view, I'm going to show that in a demo as well shortly. Once you provision a database, at one point, if there are new patches available, if there are new versions of databases available, we can do rolling upgrades right from the product itself. So that's another advantage using DSM, whereby we are not only provisioning the databases, but we're also offering capabilities around upgrades, patching, and things like that. Yeah. Besides backups and monitoring as well. Which are very critical data operations. Yeah,
backups are critical, especially for databases. Backups are super critical. Yes,
correct. These parameters or this activity is really very important, not only for infrastructure admins, but they are very important and critical for the data teams or the database teams as well as the application teams, whereby they want to also ensure that the DBs that they're consuming in their application and the DBs that they're supporting, managing the life cycle for those DBs, having correct backups, monitorings, and patching capabilities are very, very critical for them.
Yeah.
100%. Okay. So now, as you can see on the screen, again, we're gonna talk about those three important personas. So it's possible that the infrastructure admin can use DSM, as I mentioned, to relieve the data teams from having those tedious day-to-day operations, such as provisioning of databases. Instead of spending time on provisioning of databases, they can focus their attention into bringing more values to the business, such as performance tuning for the databases or forecasting the capacities for these databases. Or perhaps the data team is already stretched managing those legacy database systems like Oracles or SQL servers farms and does not have enough bandwidth to manage the cloud native databases on behalf of the developers. So this is where the infrastructure admins through DSM potentially handle that gap. And obviously there's an application team which can use the DSM UI or the ecosystem of Kubernetes tooling to deploy and manage their own services, data services as well. So DSM plays that important role and going across these multiple personas to fulfill the requirements, regardless whether it is for the data teams or application teams or even for the infrastructure admins. Yeah.
Cool.
Okay, so these are the three databases. So again, industry analysts and many of our customers have identified a clear trend towards the open source database engines, and we are listening to our customers for their open source requirements. So DSM initially focuses on these three most of the popular engines, and then the additional data services are in development. They are in pipeline. So hopefully we can see more DBs being supported by the DSM. At this point in time, if you look at PostgreSQL, we support version 12 and up. So the data service configuration, which allows the application team to add this configuration as part of the specifications. Then for MySQL, we support MySQL version 8 and up. And in case of the Alloy DB Omni, basically what is it? It is the downloadable and deployable on-premises version of Google Cloud's based Alloy DB. Currently, it is in tech preview. Soon, probably we will see it supported fully as well in production as part of the DSM. Okay.
Nice. And I also see the MinIO object store mentioned there. How about those?
Yes. So look, for the MinIO today, we are looking at offering that capability using the supervisor services. And then slightly on this particular slide as well, you can see, so the DSM is also built on Kubernetes, and it consumes as a Kubernetes operator or supervisor operator within the VMware Cloud Foundation. So so the MinIO is also being explored as one of the add-on service or the operators within the supervisor service as part of the VMware Cloud Foundation. So yes, that could be potentially a plan to go ahead and support the MinIO as well.
Okay, cool.
All right. So as I mentioned, the customers who have Kubernetes deployed and wish to leverage the database provision by DSM, the consumption operator comes in. We have spoke about the consumption operator, CCI, and Kubernetes automation in the previous episode. So the folks who haven't seen that episode, please go ahead and see that so that you get the gist of what ARIA automation can do using the CCI and for the Kubernetes automation. Something similar with the DSM as well. So the consumption operator is available, which can be installed into the local Kubernetes cluster. The operator enables multi-tenancy by adding DSM-specific binding to the namespaces. This binding includes infrastructure policies, the backup locations. Only those users with the privileged access to the namespaces are allowed to provision the database, and the data service via the DSM can only be used with those bound resources, right? Note that the consumption operator is installed in a local Kubernetes cluster that is not associated with the DSM. This enables the local user to request DSM to build a database as a normal sort of operation for them to consume the DBs. And generally, if you would like, you can request the databases, create the databases from the DSM UI or Kubernetes kube config file using the gateway APIs as well. We're going to see that in a demo shortly. Finally, as you can see on the screen, if you're using the supervisor services as well as part of the Kubernetes service, you can continue to consume the DSM operators, which are available as part of the supervisor service. And with the DSM operator, you can create the databases, you can run those databases and manage those databases. Essentially, what it does is it creates the pods. The pods are controlled and reconciled as part of the custom resource created using the API calls to the DSM. Yeah.
Right. So Pramod, this DSM objects that is being created, right? Are they going to be virtual machines, a special kind of virtual machines, or are they going to be the containers with persistent volume? How does it appear?
Yeah, so there are a few ways here. When you enable the DSM operator itself within the supervisor service, it creates that pod. The pod is the virtual machine, runs the DSM service. And then the databases that you deploy, for example, PostgreSQL using CCI, it uses the VM service operators in order to spin up the VMs and run the databases on top of it. Yeah.
Right. Okay. Probably we'll see that in our demo also, right? Okay, cool.
Yes, we will. Okay, so this is how it looks like if you use the DSM operator with the supervisor service. So essentially, the supervisor installs the database-specific custom resources into the Kubernetes cluster, the supervisor Kubernetes cluster, and this enables the supervisor Kubernetes APIs to provide the database consumption through LCI. I'm sure you and Vincent would have done that episode in the previous series whereby you talk about LCI as well, local consumption interface. So yeah, you can consume this using that. Yeah, you can consume this using LCI, local consumption interface, or you can consume this using the CCI, which is available as part of the ARIA automation, which we're going to see shortly in the demo. And there are some other options to consume DSM. So CCI in ARIA automation is one way. You can publish the cloud templates, and then those templates can be consumed from the service broker, allowing your end users to create the deployments using those templates or the catalogs. And obviously, I have to keep talking about this, that the DSM can be fully managed using the Kubernetes CLIs and APIs. And this is where you have an option to use the kube config files and the gateway APIs to create your clusters, manage your clusters, edit your clusters, and things like that. Okay.
Right.
Finally, as the last slide for me over here. So, in one slide, if I want to talk, the application team gets self-service and can use that preferred way of deploying data services while getting the automated backup and patching. Infrastructure team retains the control, which is important to them. So they retain the control through policy-based enablement. Repetitive tasks are reduced for the data teams. So essentially, if you see DSM, It provides the frictionless database as a service experience for your application team and the data teams as well.
So infrastructure team has full control. They can govern what's happening in the infrastructure. They provision the infrastructure, and application team and data team, they consume those, right? And then of course, data team can do whatever they usually do in the databases. Yeah, very neat.
Yes. All right. So are you up for the live demo now?
Absolutely, man. Yeah, let's go for the demo.
Okay. Let's go into the demo. Right. So as you can see, so this time let's keep it simple. I'm going to log in as the cloud admin. All right. So let's do that here. Again, it has a robust role-based access control. So I log in into the ARIA automation portal. I go into the service broker, and you can see under supervisor namespaces, this is where we handle the CCI out of the box from the ARIA automation. We have seen this in a previous episode, how to create the namespaces, supervisor namespaces, and how to create the TKG clusters and things like that. So let's go into our one of the previous namespace here. I click on it, supervisor namespace. As we have shown this in a previous episode, you can create VM services, you can create TKG clusters, you can create and manage the volumes, persistent volumes. You have your necessary networks like load balancers. You can use the VM images for your Kubernetes clusters as well as the VM services. And our focus today is going to be here on the DSM database. This is where you use PCI interface with ARIA automation to deploy and create databases. Okay.
So, Pramod, just to be clear, this interface that we are looking right now, that is what we call CCI interface. Is that right?
Yes, this is CCI being offered as part of the ARIA automation.
Yes. Absolutely. Yeah. Let's move on.
Okay. Now, since you asked this question, I want to quickly bring back your attention to the vCenter. And this is where you have your supervisor service up and running, right? That's the supervisor service TKGS. Under the services tree, we can enable multiple services like Grafana, Harbor Registry, VM service, CCI service. So we have enabled the CCI service, and with the CCI service, I have also enabled the DSM operator, which I spoke about in the slides. So now my DSM or data service manager operator is active, right? It's fully functioning. And then, as I said, it creates this particular pod or the VM that I spoke about. See, that's the VM we are looking at. Yeah.
Cool.
Yeah. Okay. So that's the vSphere pod which is running. Yeah. So now let's go ahead into the ARIA automation and start creating the database using the CCI. So simple workflow. Once again, we got to select the database version. So I'm creating a Postgres database. So I select the latest version 15. I'm going to give a name episode 4 demo, right? Which is what we are doing today, episode 4. Now you have an option to run a single Postgres DB instance, or you run a cluster for high availability requirements. We spoke about this flexibility during the slides. If you run a single instance, there are no replicas. But then if you run the multiple instances here, right, then you can select the technology like, you will have primary and one replica and one monitor, or you can select one primary, 3 replicas and one monitor instance. So that provides you high availability. Okay. So let's keep it simple for this demo. Single PostgreSQL instance. Now I don't see the multiple replica option because it's a single instance, right? So I select that. Database name, I'm going to keep it simple like my instance name. I can also create new admin user for my database instance. So that's the PG admin, right? Click next here. Now we are dealing with the infrastructure policies that are provided to me by my infrastructure admin, right? So let's see what infrastructure admin provided me. They have given me only one policy to use. It's called Infra Gold. And in Infra Gold, they have offered me vSAN storage. So I can see my vSAN storage policy. And how many t-shirt sizes they have given me in this Infra Gold policy? They have given me 3: small, medium, and large, right? So I can probably use pretty small for this deployment. I can define the disk size for my instance. So 60 GB looks good for me, but if I wish, I can change this, right? Click next. Again, remember the day 2 capabilities in order to maintain the databases, enable the backups, run the backup, make sure that you have backup copies of your database. So you can do that as part of a day 1 itself when you're provisioning the databases now, right? So do you want to enable the backup? Yes, it's on. Where do you want to store the backup? My infrastructure admin has provided me this as a backup location to store my backup. Okay.
So what is that? Is that also VCF?
No. So for this, I'm using MinIO because this is the S3 bucket. And in S3 bucket, I'm going to store my backup. So I'm using MinIO for this configuration.
So it's basically an object store to store your backups.
Yes, absolutely. Yeah. Now, your backup retention period, how many days you want to retain this backup? What's your retention policy looks like? You can, as per your choice, you can select this. Now, move into the maintenance. Do you want a maintenance window? Now, this is where it explains you very clearly. Enable maintenance
Yep.
window will allow CVEs, bug fixes, new lifecycle management features, and minor version upgrades to be addressed. All right. And also, it will not lead to any downtime when the database is deployed with replication. You can have multiple copies. Remember, high available 3 copies or 5 copies in that configuration that we saw earlier. Yeah.
That
So
cluster configuration. Yep.
as long as you have those replication copies, you could, have an online maintenance window. Now, if you have
All right.
single, then obviously there will be there's no replica, so there could be a downtime, right? So you can set the maintenance here, which day of the week you're running maintenance, whether it is Friday or Saturday. So let's keep it Saturday. What time you're going to run the maintenance? So it's a midnight, around 11:59 p.m. And how long your maintenance window should run. So about 6 hours. You can change this as per your requirements. You can have advanced settings for your databases. If you wish to add some advanced parameters for your database configuration provisioning itself, you can do so. But
Yes.
we're going to keep it simple.
So these are the configuration that database parameters that database administrator team or data team may want to use to optimize the databases, right? So those are the special configurations.
Yes. Like how many threads and things like that. Sometimes they define those into the database options. So that can be defined as part of this provisioning, right? Now, once I say quick next, I can see the summary of my provisioning, what I'm trying to do to provision this particular PostgreSQL DB. And at the same time, what we have seen in our Kubernetes automation, you can also see here the code been generated for you, right? So this code is generated while you're configuring your provisioning, and then you can download this code, which you could use it at a later stage. All right.
Yeah, so same as any other thing that we did before. Everything has YAML configuration. Cool.
Correct. And this is what I have been keep calling. You have flexibility to consume Data Service Manager or DSM using Kubernetes APIs, gateway APIs, also from the UI, also from the CCI, and from the cloud template elements using the catalogs as well, which we're going to see shortly. Okay. So let's go ahead and create this. So I just clicked on create, and this is in progress. What I will do is while this is going on, we can see our existing cluster that we deployed here, pSQL demo. So if I expand this, you see you can view the YAML file of this configuration. The instance name was SQL demo that was running 15.8 version of the PostgreSQL. The status is ready. The database name also you can see here. You can see how it was configured, whether it was configured in high available manner with multiple replicas, but this is a single instance, so there are no replicas here. You can see the instance IP address as well for database, what infrastructure policy that you use. And as a day two, if you wish to edit this, obviously you can edit this as for day two operation. For example, this single instance running with this small t-shirt size VM class, you can scale this up, right? So you can expand to the medium a lot.
Yeah, so about that disk size, right? So let's say if I make it from 60 to 120 gig, is it going to be live disk size resizing?
As long as you have the multiple replicas, there won't be any disruption. Yeah, if a single instance that you're running, I would advise to work with the proper maintenance window for it.
Absolutely.
So that's the thing there. Obviously, you have backup configuration. So you can see when you provision this for the first time, obviously it runs the full backup, and it is running full backup on every week Saturday as well. And then all other days it runs the incremental backup, daily incremental backup as well. Okay. There is a maintenance window defined here, right? So a lot of things you can do from the CCI as well with the provisioning and data capabilities. Now let's go back to our DSM service. And you can see this instance is coming up as well. Now, how can we see this instance from the DSM UI? So let's go into the DSM UI quickly, right? So if I log in.
How do we access DSM UI, by the way?
So when you deploy the DSM instance, obviously you will have a fully qualified domain name or the IP address. So you access it using fully qualified domain name of your DSM instance. And this is how it looks like, right? So currently on a dashboard, it shows that I have 5 PostgreSQL. I don't have any MySQL DB currently running. I have 2 users. I can use Active Directory LDAP integration for the user management and role-based access control as well. So let's go ahead and see our databases. Now, this is the DB that I just provisioned using CCI. Currently, it's in progress. We can check what's going on as well. So say it is episode 4 demo, exact same information what we given. But I want to bring your attention to a existing DB. For example, this is the DB that we saw earlier. That was the DB. Let's go into this, and you can see you have similar information what you have provided, but then if you wish to do the management of your database using the DSM UI, you can do so, right? You can change the replicas to 3. That means 1 primary, 1 replica, 1 monitor instance. So you're creating high availability here. You can change your infrastructure policies, the t-shirt sizes, the disk size, and so on. But then the important thing here is I want to show you one database which has the rolling upgrade available. So let me see if it. Okay, unfortunately, most of them are updated one. I don't see any rolling upgrades available, but let me see. Yeah. There are no upgrades available at this point in time, but in case there are upgrades available, obviously you can select those and do the rolling upgrade and patching from here. Okay. When it comes to the lifecycle management using DSM, you can do lifecycle management and patching of your DSM system and or the databases as well. So, for example, for data services, MySQL and Postgres, currently these are the database versions available. If the newer versions are available for us to upgrade and patch, we can do so from the system. So over here, you can click on check for upgrade and you will be able to see the new patches in the bundles. Right now, similar thing you can do from here as well. You can create new databases. What we have just seen, for example, MySQL from the DSM UI, we support 8+ versions for MySQL. So you select whichever version you want, give a name, select the topology, and everything going to be same what we have done from the CCI using Array automation. Okay, so the same thing you can do it from your DSM UI. So let's go back. Let's go back into the service broker. Now, Array automation, you would have seen in my previous episodes, you can consume the self-service catalog for your various database services. So for example, if I want to provision some databases using the catalog management, I can do so as well. So for example, I selected my relevant project. Project is a bucket of infrastructure and the logical boundary allowed to me to consume. I can give name like episode 4 catalog, episode 4 catalog. And then what database engine I want to consume? I want to consume MySQL here. So I can select MySQL. Then it gives me what database version that I need. For example, 8.0.34. What topology I need, whether it is single instance without any replica or a highly available instance with multiple replica. I can do so. So keep it simple. Step one. What infrastructure policy provided to me by my infra admin? It's a gold. What we have seen this in the CCI as well. Storage policy. It's a vSAN storage. The t-shirt size for my SQL instance, probably small. How much storage that I need. Whether I want to enable the Active Directory integration with this instance, I can do so, but I'm going to keep it simple. Whether or not I need backup, if I disable this, there's no backup. If I say enable backup, then I can define which backup location I want to put the backup, how many days I want to retain the backup, whether or not I need maintenance window. If I deselect that, I don't get any maintenance window, but if I select this, I can define which day of the week I want to do the maintenance, when I want to do the maintenance, how long the maintenance should go, and then the database options as well. Remember, we have seen all this from the CCI, but then you can now, as a provider, as a cloud admin or as a provider, you can package this into a catalog, and then you can offer this capability to your consumers, which could be your data teams, your application team. So when they log in into their self-service portal using Array automation, they see that tile there, a catalog, and they do this provisioning, right? Now,
so I really like this. Just a quick question. Yeah, quick question on this one is, so how do you build that catalog for DSM?
Yes, I'm going to show you that. Good question. That's the episode 4, which I tested this morning. It was successful. I can see here all the details of my Postgres instance, running the DB workloads and all the infrastructure policy. If I wish, I can get the connection string from here, get connection string, and it provides me the connection string that I can use for my applications and things like that. Now, how did I provision this? How did I prepare this particular catalog? So using this template. So if I go into the template, so let's go into the assembler.
Did you create that template from scratch?
Yes. So that's the database service. If I open this, there are a few ways that you can create this. Now, what I'm doing here is this one is coming from a custom orchestration workflows, right? We're going to see this into the next episode when we're going to talk about the extensibility and the orchestrator capabilities. So this is done using the Python scripts and the custom resources and the orchestrator workflows. But I will show you another one like this one. This is using the CCI elements, what we have seen in the previous episode. So you can use the supervisor resource, TKG resource. So mainly my DSM DB, you can see here. You can see here this is using supervisor resource, and we are defining the same parameters. You can see here what the user name, what's the storage space, what's the storage policy name, what's the infrastructure policy. Remember this infra goal? That is what we use. Or t-shirt sizes, the database configurations, and all the things that we have done using CCI or what we have seen using a catalog item. You can do this using the cloud assembly, cloud templates as well. I hope that answers your question, how we build this out.
Yeah, absolutely, man. So multiple ways of doing things. Yeah, it's pretty good.
Yes. So let's go back to the service broker and see the status of our database that we spun up shortly. So here, 2 databases. And there you go, episode 4 demo. It's fully up and running. Okay. So what we have seen so far, we have provisioned the DB using Array Automation's CCI capability, right? We have seen the DSM UI itself, how you can create the DBs, how you can manage the databases and things like that. Then we have seen Area Automation, another option to package your database as a service and offer it as a catalog item for your end users. And on top of this, you can then put approval policies, you can put lease policies, and all that great things that we have seen in episode 1, episode 2, and episode 3. We can all do that here, right? And then finally, I want to quickly show you from a infrastructure admin, what can you do with the DSM? So if I go into the vCenter now, in vCenter, I have this VMware Cloud Foundation with multiple domains. This is the 01 is my management domain. This is my workload domain and another workload domain. So if I select this workload domain where I'm doing all the action into this, if I go select that vCenter, workload domain vCenter, and go into the configure, you'll see there is a plugin for DSM, Data Service Manager. And this is where you can define your infrastructure policies. Now, remember, we have been consuming this infrastructure policy from CCI and from the Cloud Assembly catalogs. The same thing is coming from here. This is where you define the infrastructure policy. And this is where then the infrastructure admins or the VI admins gain control and manage the governance for this sort of a deployment, right? So this is all here. They can create the IP pools. They can expand the IP pool. So currently I'm using 15 IPs out of 31 IPs. They can create the VM classes, the t-shirt sizes. If someone says, I need a bigger database and your large size cannot support me, then the VI admin can create one. Or the VI admin can let the data teams or the application team to create this new policies by themselves and manage it. So again, depends what's the strategy and how they want to manage and maintain this. So let's go ahead and see what we can do using the API gateway. So this is my Linux system, right? Now, what I need to do is I need to go into the DSM UI and get the kube config file. So you can download this DSM kube config file, which I have already done. If I show you here, I have moved that kube config file here. Okay, so we're going to use this kube config file to run the Kubernetes API, the Kubernetes CLI using that kube config file. So as usual, first things first, we always need to log in, right? So I'm logging into my cluster, which obviously I need to do. Now, once I log in, I can see all this context available for me, right? So I can go ahead and use my DSM operator context. Remember, I showed you this vCenter supervisor service. So I'm using switching to the right context. Now I can run some of the commands like kubectl get all. I can see all the data services, database services related parameters in my cluster. See, consumption of DSM operator, the webhook, and how it's running those pods and things like that. Remember, I mentioned it runs it as a pod. So that's how it runs as a pod. So then I can check the infrastructure policy. So that's the infrastructure policy info. Then I can check the other parameters as well, like where is my backup location, right? So that's the database backup location. Now, if I wish to get more details into what all API resources are there into this DSM operator, I can check the API resources, like how many secrets, how many IP pools and things like that I have. But probably I bring your attention to this quickly. Can we also use the Kubernetes APIs to find out my Postgres SQL clusters? So the command is kubectl get Postgres clusters using that kube config file. You can see I have my cluster here. Now, can you manage these clusters? So the answer is yes. I can go ahead and use the PC DSM cluster and see what I can do with it. I can get the entire configuration manifest file for my cluster, right? So this is the manifest file for my cluster, and you can see all the necessary parameters are here, like the backup location, right? The backup location, the retention period for backup, the infrastructure policy here, the maintenance window, and how many replicas. So this is running a single instance. Now I want to show you something. Can we modify this PostgreSQL cluster using the kube API commands directly? Because remember, during the slide I mentioned application teams desire to use their own toolings, like if they're consuming other application resources using the kube APIs or CLI, then they can manage the DSM using this as well. So I'm showing you, instead of just viewing the configurations and the details and things like that, can the application team edit this configuration? So let's go ahead and see that, right? So I'm an application team. This is my cluster. I can just edit the replica. So let's find replica, which is on line 55. Let's go ahead and modify this to 1. Okay. That means we are now scaling. Instead of running single instance, we're going to have one primary, one replica, right? So I change the replica to 1 and I'm saving this deployment. See, now Postgres database, this particular cluster is edited. Now, if I get a list of my Postgres cluster, give me a second. Get clusters. See here. Now it's scaling the so it's scaling it. We can see the same thing from the DSM UI as well. So
Oh, yeah. Scaling, yeah.
this is scaling the replica. Now it's moving from a single to multiple replica. See, scaling
Yes,
replica.
wonderful.
That's the beauty of automation and VMware's Data Service Manager integration, whereby you have various options that cater for the needs of various personas. So infrastructure
Yeah.
team can manage the infrastructure policies, governance and control. The data teams can now use self-service capabilities to spin up their databases using CCI, cloud consumption
Yeah.
interface within the automation, or they can consume it using the self-service catalogs. The application team can also do the same thing using self-service consumption catalogs and the CCI. And both of these personas can consume, manage, operate the databases using the Kubernetes APIs and CLI as well. Yeah, that's pretty much I wanted to cover for the database automation using ARIA automation as part of a self-service
Right.
capabilities.
So for the vSphere infrastructure admin, right? In the vCenter console, how do this DSM component look like? Can you have a quick peek look on that? How
Yeah,
it looks?
yeah. Remember, so if I go into the vCenter, when we enable or when provision the DSM or Data Service Manager appliance, it also registers a plugin. So this is the plugin that you see, right? So once you register the plugin, this is where then you can start creating the new infrastructure policy. For example, as a VI admin, as you asked, I want to create infrastructure policy. I can give a name here. For example, let's do episode 4 infra policy, right? Then next, which cluster you want to offer as part of this infrastructure policy. If you have multiple clusters, you can select, but in this case, this is my workload domain within the VCF. So I select that cluster. Click next and select the storage that I wish to use. So I can select the storage-based policy. For example, I want to use the default policy. Click next, I can do that. Then I can select the network that my DB is going to consume, what network I want to allow them to. So all these things you can do as part of the VI admin setting up the infrastructure policies. Beside that, you can also set up something called Active Directory Service. So this is where infra can set up the open LDAP and Active Directory integration so that you manage the role-based access control.
One of the database cluster we have created earlier, right? Can you show me in this particular PI cluster, how is it appearing, that object? Do we have that object representation?
Yes, so let's quickly check, right? So the one that we created, let's see the name, right?
Episode 4 demo.
Episode 4 demo. Let's go ahead and check here. So that's the one.
All right, so that's the one.
Yeah, so remember that's my workload domain within the VMware Cloud Foundation.
Resource.
Yeah, episode 4 demo. So it has now got the IP address, it got the things running on this. Yeah, so that's how.
So that's where the Postgres database is running, right? Okay, cool. Got it.
Yes. Yeah. And remember I said it uses the VM service. So it has used the VM service to create that particular virtual machine with the necessary things. If you scale this up, then you will see multiple instances running. So for example, you see here, the one that we just scaled, the scaling replica, I think this is still going on. This would have done.
It's happening,
So so then it spins up this like pSQL. So that's a VM name.
pSQL DS. So those are the VMs.
Yeah, those are the VMs. So the secondary replica is still coming. Yeah.
Yeah, got it. So those are the VM names. We can actually track it back to the vCenter. Got it, man. Oh, awesome. This is really good.
This is pretty much I have to share today as part of this episode.
Awesome, man. This is an excellent demo as always, man. And really appreciate that. Great to see this fantastic capabilities of VCF automation for databases.
Perfect.
Awesome, man. So for our viewers, so join us in our next episode. We will be exploring extensibility, orchestration, and third-party integration with VCF automation. I really appreciate your time, Pramod, as always. And for everyone, till then, have a great one, and then we'll see you again in the next one. Thanks all.
See you
guys.
Bye. Yeah, bye-bye.
Bye.